Hello everyone. For those of you that do not know me, I am Mr. Stock. For those of you that do, you're hearing a familiar voice. I hope the Unit 2 test went well. If you could please find this piece of paper for the notes, and on the back is the homework for our post-test homework. That would be great. The first thing we're going to do is we're going to review simplifying radicals. The main idea is we want to factor out a square. Okay, so there's two methods to doing this, depending on which one works better for you or who you had as a teacher. The first idea is to think what perfect square goes into 18. If I'm doing the perfect squares, you can put y equals x squared in your calculator, and then go to the table to see what they are. What we're looking for, does one of these numbers go into 18? And 9 goes into 18 twice. Okay, and then the whole idea of this is once we've factored out a perfect square, now you can square root that 9, and our answer is 3 radical 2. The other method of doing this is to factor 18 into all of its primes. So you could factor this to be 6 and 3, and then you can factor 6 to be 2 and 3. And then the idea was to pair them up. So when you take the square root of something, it's either from one of two identical pairs. In algebra, we talked about pairing them up. One breaks out of radical jail and the other does not make it. But whichever method you use, you should end up with 3 radical 2. Now I'd like to show people how we can also check that we did that correctly. So if I go to my calculator, if I type in my initial square root of 18, it gives me that decimal. And if I type in 3 square root of 2, I should get the same decimal, and that tells me that I did that right. Okay, so that's just one way that you could check on what you're doing. All right, the next one is 45. Pause the video, see if you can figure out what perfect square goes into 45, or do the prime factorization. So whichever way you decided to do it, if you do the prime factorization method, I started out with 15 and 3, you could have used 9 and 5, but we had 2 3s that paired up. One of them breaks out. If you use the square root method, the perfect square that goes into it is 9. The square root of 9 is 3. And again, if you wanted to check with your calculator, you type in your original, you type in your answer, and you make sure that the decimals match each other. Okay, please pause the video and try the square root of 75. So whichever method you use, if you break this up and use 25 and 3, okay, and then I break it up further, looking for one of the pairs of factors to break out. The other method, 25 is our perfect square, and we end up with 5 radical 3. Okay, the last example has an extra constant out in front of it. So what we have to remember is at the end of this one, we're going to multiply our results by 2. So if I'm thinking of which perfect square goes into 32, there's actually 2 of them. 4 and 16 go into 32. You want to use the bigger one, so you have less work to do. So 16 would go into that twice. The square root of 16 is 4. And when we do that, we're always going to multiply the 2 numbers that come out in front. And I'll end up with 8 radical 2. If you're using the factoring method, you might have picked 4 and 8. You could break this down to 2 and 2, 2 and 4, 2 and 2. So we have 5 2s. One pair breaks out, another pair breaks out, and we multiply them. have 2 times 2 radical 2. And the one thing that we cannot forget is to bring the original constant out in front to give us 8 radical 2. Right? So when you started doing this in algebra, you probably didn't have a lot of context when you're doing that, besides using the square root function. And the square root function comes into play a lot in geometry if we are trying to find the missing side of a right triangle. So the Pythagorean theorem is a squared plus b squared c squared. The one thing we have to remember is that c is the hypotenuse, and the hypotenuse is always the longest side of the right triangle. So the first thing we want to recognize is where is the right angle across from that always has to be c. A and B are called the legs of the right triangle. Those are the 2 sides that make up the right angle. So I'm going to use 6 as my A, 11 as my B, and then my C is going to be X. So you can type this into your calculator. So I got 157 for my answer. So 157 equals X squared. If we want to get rid of a squared or we want to undo it, we will square root both sides. Technically, there would be a plus or minus in front of this square root, but because we're talking about the side of a right triangle, we ignore the negative because you can't have a negative distance. So I end up with X equals the square root of 157. Now, in the directions, it says simplest radical form, or it might say to find the exact answer. The only time we're going to type square root of 157 in our calculator is if they want us to round to the nearest 10th, 100th, 1000th, something like that. So 157 is a big number. I want to give you another idea of how we might factor that. So we go back to our calculator. And in my calculator, if I go into y equals, I can type 157 divided by x. And then I can go into the table by hitting second graph, right? And then I can start looking through the table to see, are there any values that go into 157, and more specifically, are there any perfect squares? So you can scroll down through this, right? There aren't any numbers that go into 157. Okay, so since this is not, you're not able to simplify it, that would be your answer. All right, so the first thing I want you to do is figure out which side is going to be our C, and then set up the Pythagorean theorem. So I always try to find the right angle first. Side across from that has to be my C value, okay? And these 2 sides are also radicals. When I square a radical, square root will cancel it out. So we've done that with 6 plus 15. Instead of being 21 equals x squared. To get rid of the squared, I would square root both sides. And then again, I start thinking about, are there any perfect squares that go into 21? The only 2 numbers that go into 21 are 3 and 7. Our whole goal is to try and find a perfect square or 2 factors that match. And since that doesn't happen, we end up with the square root of 21. I would like to try and pause the video and see if you can, how far you can get through on this problem. When you unpause it, then you can see how you did. All right, so I got the square root of 244, okay? And now I have to make sure, we did the directions, it has to be in simplest radical form. So now I need to try and simplify that. So again, when the numbers get a little bit bigger, it's not a bad idea to go to your calculator. And in your calculator, you can put 244 divided by x. And then you can go into the T-chart. And I'm looking for, are there any perfect squares? So I see, 1 and 244, that's not going to help me. 2 and 122. 4 is a perfect square. Okay, and I would think to myself, could I break 61 down any farther from that? And the answer is no. So I'm writing this up into 4 and 61. And the square root of 4 is 2. So my final answer would be 2 square root of 61. And again, I would encourage you to check in your calculator by typing square root of 2.4 and 261 into it. Okay, this is the last example that we're going to give you. So the first thing I want you to do is set up the Pythagorean theorem. And this one's a little bit trickier because the radical has the 2 and the radical 3. So in the calculator, if you're going to type it in, you need to have the parentheses around the entire thing, or else it won't square both numbers. Okay, if you're doing this without a calculator, you're actually going to square the radical 3 and the 2. So in my calculator, I'm going to use parentheses. So parentheses 2, radical 3, close the parentheses squared, should give me a value of 12. Right? So get x squared plus 4 equals 12. And now we need to use algebra in order to get the x by itself. Subtract 4 from both sides. And then square root it. Please pause the video and simplify radical 8. Okay, so your final answer should be 2 radical 2. Again, in this problem, be really careful that if you put the hypotenuse 2 radical 3 inside parentheses, so that's squaring both of them in a calculator. Okay, but we will be using the Pythagorean theorem throughout the whole year. So you can always come back and watch this video. The last thing that we're going to do is they may ask us, is this a right triangle? Okay, and don't look at the picture and say it looks like a right triangle. We're actually going to use the 3 side lengths to figure out what is there. So if they want to know if it's a right triangle, they're asking us, does a squared plus b squared equal c squared? Okay, so I want to see if both sides of that come out to be the same number. Right? And for this problem, would you mind changing this 6 to 4, please? So if I'm looking at it, it looks like right there would be my right angle. So that would make 4 radical 5 my hypotenuse. So I'm asking myself, does 8 squared plus 4 squared, does that equal 4 radical 5 squared? Again, really important that you type that in your calculator using those parentheses. But please put both of these in your calculator to see if they work. So if you type in both of these in my calculator, again, using those parentheses, I get both sides are 80. So both sides end up being 80. Okay, this is my justification right here, is all of that. All right, but my answer is this a right triangle? Yes, it is a right triangle. Okay, if it's up to explain, then we'd have to say that the 4 sides satisfy the Pythagorean theorem. So then you can pause the video and try the last one on your own to determine if it is a right triangle or not. So we're asking ourselves if 14 squared plus 19 squared equals the square root of 421 squared. And I'm going to put this in my calculator. This side was 557. This side was 421. Those do not equal each other. So no, it is not a right triangle. Okay, so these two things are going to come up over and over again. We're going to have Pythagorean theorem. Typically, we're going to have to simplify the side that we are missing. And again, if they said exact value or simplest radical form, that means you need to use these two techniques. Please turn the paper over and try your homework, and good luck in unit 3.